Okay, I'm going to go through the answers on the Education Perfect test. It might take a couple of videos because I only have 15 minutes per video. I really need you to be watching these videos, taking notes, paying attention, trying to understand. Don't just watch and like it's a movie. Watch it like you're trying to understand, because I'm very worried about most of the classes where they're at and how much they've taken in. I've created so many videos with so many examples, and I feel like people aren't really using them the way they should be. Right, we're going to do the first question. Approximately 10% of the New Zealand population is left-handed. So I'm given a probability, a fixed probability, in a random sample of 6 New Zealanders. So now I have a fixed number of trials. What is the probability that none of them are left-handed? So I have a probability, which I know is 0.1. And I know I have a fixed number of trials, which is equal to 6. Now, if I have those two things, then I have the binomial distribution. And I'm trying to work out the probability that x is equal to 0. So, if it's equal to, wrong thing, then I'm going into BPD in my graphics calculator. So stat, it's a binomial distribution. I need BPD. My number of trials is 6. I'm looking for the probability of 0, that x equals 0, and my probability is 0.1. Now your question might be different on your test because the numbers are randomly generated. And I get 0.531. Cool, and that's done. The next question, if 2 random samples of 6 New Zealanders are taken, what is the probability that at least one of the samples contains no left-handed people? Now, this is slightly harder. So now we actually have 2 as our number of trials. We're taking 2 samples of 6 New Zealanders. So n is equal to 2. We're looking at 2 trials, and don't worry about that question mark. We know that the probability that there's no left-handed people out of our 6 New Zealanders is 0.534. Now, so what I've done is I've created a new binomial distribution based on information from before. So now I've only got a sample size of 2, and the probability of success that there's no left-handed people in that group is 0.534. And now I'm trying to work out at least one of these 2 contains no left-handed people, this probability. I'm trying to work out the probability that x is greater than or equal to 1, x, which is going to equal 1 minus probability that x equals 0. So I'm not using this probability here. I'm working out the probability that so at least one of the samples contains no left-handed people. Now I'm working out the probability that none of those 2 samples, so 0 of those 2 samples, has no left-handed people. So sorry about that. So I'm going to still use 0 as my x. My number of trials is now 2. My probability is now 0.534. And I get 0.217. So it's 1 minus 0.217, which gives me 0.723. What happened? Oops. 7, that's what happened. 783. There we go. Bad minusing. Okay. Next question. Michael shoots 25 free throws every morning as part of his basketball training schedule. So we have a fixed number of trials. N equals 25. Already looking like it is a binomial distribution. 5 out of 7 are successful. So that's my probability. Probability equals 5 out of 7. Don't worry about the question mark. Gets confused. What is the probability that at least 20 of his shots are successful? So I need the probability that X is greater than or equal to 20. Now remember that I want 20, 21, 22, 23, 24, 25. My calculator only does less than or equal to. So I need to go 1 equals 1 minus probably the X is less than or equal to 19. Because if I take off 1 to 19, that'll leave me 20 to 25. So I need to go 1 minus and do it in my calculator. So I need BCD this time, binomial BCD, because I want less than or equal to 19. I have an X of 19, that's the one that's in the brackets. I have a number of trials of 25. And I have a probability of 5 over 7. You can use the divided by, you can use the ABC button, but it's 5 over 7. It's my probability, 5 out of 7 successful. Okay, and I do that, press equals, and I get 0.7613. 0.761, leave it like that. And that equals 0.239. Okay. What is the probability that Michael has at least 20 successful shots on no more than 3 of the next 5 mornings? Okay, so now this is like the last question as well. So now I have a number of trials equaling 5. Oh, I don't know what that line is. And I'm trying to work out the probability that X is less than or equal to 3. What is the probability that Michael has at least 20 successful shots on no more than 3 of the 5 next morning? So 3 out of these 5. Now the probability he does have more than 20 successful shots, so his probability of success is equal to, we worked it out before, 0.239. So I'm going to use this information in my calculator. It's already less than or equal to. It's nice and easy for me. So I need my X is 3, my N is 5, and my P is 0.239. And so my answer is 0.99. Okay, I'm going to stop there because the next ones are on Poisson.